When it asks you to FOIL or box something together, it means that you're going to be multiplying two factors together, or maybe more, to create a polynomial. A very simple example would be 3 times 4 equals 12, or x times x equals x squared. You're multiplying things together. So when you do FOIL, it stands for first. You take the first item in each of the parentheses and multiply those together. So x times x is x squared. Then you take the outside, so the x and the 4. 4 times x is 4x. Then you take the inside terms, so 5 and x are on the inside. And then you take the last terms in the parentheses. So the 5 and the 4 are the last things listed in each set of parentheses, and 5 times 4 is 20. The final step is to combine your like terms, and your final answer is x squared plus 9x plus 20. Go ahead and try 1b. Hopefully for a 1b, you got x squared plus x minus 12. You could have a 1x, or you could just have plain x. It doesn't matter. Now let's do the same exact thing, except for this time with the box method. So to make a box, we have 2 items by 2 items. So I'm going to draw a box. I draw the side and the top, and I split each side into 2 sections. So I'll put the x and the positive 5 on the side, and I'll put an x and a positive 4 on the top. Now I'll go through and multiply. So this side times this side, x times x is x squared. This side times the top is 4x. This side times the top is 5x. And this side times the top, 5 times 4, is 20. Last, I'll combine my like terms, and my final answer I'll write over here is x squared plus 9x plus 20. So same exact answer as I got doing FOIL, it was just a little different. So let's see if you can try 1b. Make sure when you set up your box you have an x and a positive 4 on one side and an x and a negative 3 on the top. And you should get the same exact final answer as we got in the other 1b when we FOILed. It's really up to you which method you use, but you can fill in the answer to that question right now if you like FOILing or boxing better. So I just told you that FOILing is multiplying, which means factoring is the opposite. Factoring, you're dividing. You divide a polynomial into factors. So this time we're going to start with the answer. Instead of multiplying 3 and 4 together to get 12, we're going to take the answer 12 and divide it by 3 to get 4. So 3 is a factor and 4 is a factor of 12. Or if we took our answer x squared and we divided it by one factor x, the other factor would be x. So that's what we're going to do when we factor. We're going to be working kind of backwards from FOILing or boxing. So the opposite of factoring is FOILing, and the opposite of unboxing is boxing. So if you look at these problems in in example 2, you're going to notice that from standard form, which we learned in section 5.2, when we have ax squared plus bx plus c, all these example problems have the very first number in front of the x squared. It's 1. In other words, there's no number in front of it. There's a 1 in front of the x squared. So these are the most straightforward to do. When a equals 1, all you need to do is find the factors of c that either add or subtract, and you'll know, depending on what that sign is right there, to get the letter B. So whatever B is. So we kind of work backwards. You find the factors of C that add to get B, or subtract to get B. So let's try that with 2a. I know there's going to be 2 factors, so I have 2 sets of parentheses. There's 2 factors because that's an x squared. And I know from FOILing that x times x gives me x squared. So I've taken care of the first step. Now I just have to find the factors of c, so I need factors of 20, what multiplies together to get 20? Well, 1 times 20, 2 times 10, and 4 times 5. These need to add together to equal positive 9. So 1 plus 20 is not 9, 2 plus 10 is not 9, but 4 plus 5 is 9. So I'm going to put a positive 4 and a positive 5, and that's how you factor. If you notice, that was the question in the first example when we got that for the answer. Let's see if you can try 2b. Your first step, it's kind of a no-brainer. There's two factors. X times x is x squared, so we have two sets of parentheses. Now you're trying to find the factors of 12 that subtract to give you positive 1. So I looked through all the possibilities for the factors of 12, and I know if you subtract 3 and 4, you'll get 1. So the question is, which way do you subtract them? Do you do 3 minus 4? Because that's negative 1. We want positive 1. But 4 minus 3 is positive 1. So I made the 4 positive and the 3 negative, and we're done. To unbox, what we're going to do is take the first term and put it in the upper left-hand box, and we'll take the positive 20 and put it in the lower right-hand box. And now we just have to figure out the factors that go right there. We know, just like before, that the factors of 20 have to add up to give us positive 9. So we already know it's 4 times 5. So it doesn't matter which box we put the 4 and the 5 in, but since it's 9x, we're going to put 4x and 5x. Now what we'll do is we will pull the GCF from each row and each column. So the greatest common factor of x squared and 5x is x. The greatest common factor of 4x and 20 is 4. Now we'll look straight down the columns. The GCF of x squared and 4x is x, and the GCF of 5x and 20 is 5. So you can see what we have on the side and what we have on the top. Those are our two factors. That's x and a positive 4, so x plus 4, and x and positive 5, so x plus 5. It does not matter what order you write your factors in. Writing that and writing this with the 5 and the 4 switched, they both are acceptable answers. Your first step is to put the first term in the first box and the last term in the last box. So obviously we know the final answer to this question is that right there. Let me show you how we figured out the sides. I put positive 4x and minus 3x because 4 minus 3 is 1. Now for the GCFs. The top row, x squared and negative 3x, the GCF is x. For this row, I have positive 4x and negative 12. Since only this one had the negative sign and there's a negative sign on top of it, I'm not going to worry about it in the bottom row. So the GCF was just 4. The GCF looking down this column was x. And now looking down here, since they both had a negative sign, I took the negative sign out up there. And then they had a GCF of 3. So x plus 4 and x minus 3 were the two factors. Now you'll decide which of those methods you like better, and then explain how FOILing and factoring are related to each other. If you forget, you can rewind the video and watch that part again. For all these problems, we're still trying to factor them, but in this case, the number in front of the x, the a is not equal to 1. So it's like 2, 3, 4, 5, it's something other than 1. So the first step we have to do is see if there's a GCF that we can factor out. We'll divide all the numbers by it first, and if there is, then we can continue like we did on the first side. If not, we're going to need to find the factors instead of just c. We're going to need to find the factors of a times c and add or subtract them to get b. So the rest of these examples are when a does not equal 1. Once you do get the first number in front of x squared equaling 1, then you're just going to do the problems the way we did in example 2, like I just said. So let me show you how to factor by grouping if necessary. So this first problem, we're going to try to see if we can find a GCF we can divide all three terms by. So what goes into 6, 1, and negative 2? Well, the biggest number we could divide them all by is 1, and that's pretty lame. We could try to divide them all by an x, but that 2 doesn't have an x. So there is no GCF for us to divide all of that by. Dang. So what we're going to do is multiply a, so 6, and c, which is negative 2. We're going to multiply those together. So 6 times negative 2 is negative 12. So we're going to find the factors of negative 12 that subtract to get positive 1. So let's think about it. There's 1 and 12, 2 and 6, and 3 and 4. And actually from the first page we already know that 4 minus 3 is positive 1. So we're going to put these into our polynomial by first recopying the first term. So we're going to write the 6x squared. Then we're going to write our plus 4x and our minus 3x. And then finally we'll write the minus 2. So all we've done is we've split the 1 into the plus 4 and the minus 3. We recopied the 6x squared and we recopied the minus 2. Now we're going to group these into two separate parentheses. So I'm going to take the first two terms and group those together, and then the second two and group those together. Notice that negative sign goes with the 3 because it's in front of the 3. So now I'm going to find a GCF for the first set of parentheses. Now that they're separate, I'm just going to deal with the first set. So what can we divide 6x squared and 4x by? Well, 2 goes into both of those numbers, and we can divide an x by both of those. So I'll put the GCF out front, so 2x, and next to it in the parentheses I'll put the leftovers. 6 divided by 2 is 3, and x squared divided by x, 2 minus 1, is just 1, so x to the first. Now we have a plus sign. 4 divided by 2 is 2, and those x's cancel out. Now I'll do the same thing with the other set. I'm going to see what I can divide both negative 3x and negative 2 by. Well, the biggest number that goes into each of them is 1. Both of them don't have an x, but they do both have negative signs. So whenever you have a negative for both of them, you should always pull that out. So I'm going to write my GCF next. So my GCF is negative 1, and I'm going to write the leftovers right next to it. Negative 3 divided by negative 1 is positive 3, and there's an x. Negative 2 divided by negative 1 is positive 2. And now you'll notice something interesting happened. We have a factor 3x plus 2, and we have another factor 3x plus 2, and they match up. So now out of the whole polynomial, those become our new GCF. If you think about dividing each term by 3x by 2, or 3x plus 2 and 3x plus 2, they'll cancel out, and we'll write that GCF, the 3x plus 2, out front. Now all we have to do is write the leftovers next to it. So what was left? The 2x and the minus 1. So that's our answer to what got FOILed together to get that for the answer. You're welcome to FOIL it to check just to be sure. Your first step in 3B is to look and see if there's a GCF you can divide all three terms by, and there is. It's 3x. So I wrote the 3x out front, and then I canceled everything out and put the rest of it in parentheses. Now I will continue by multiplying a and c together and finding those factors. I want the factors to add up to 11. So 3 and 8, positive 3, 8 are going to be the winners. So I rewrote everything, the 3x, the 12x squared. I wrote the 3x plus 8x instead of 11x and the plus 2. Now I'm going to split those into two sets of parentheses. This one had a couple more steps, so study it. After I wrote that last line in black, I split it into 2 and 2. The plus sign went with the 8. The GCF of 12x squared and 3x is 3x. So I recopied that 3x. I recopied that parenthesis, and then I wrote this GCF, the blue one, the 3x, out in front, and I wrote the leftovers next to it. So 12x squared divided by 3x is 4x. 3x divided by 3x is 1. I did the same thing for the second set. The GCF of 8x and 2 is 2. So I divided both of those by the GCF. It's a positive 2, so I put a positive 2. And then next to it, I put the leftovers. 8x divided by 2 is 4x, and 2 divided by 2 is 1. So I recopied that 3x out front again, and then I got rid of the common factor they had, the 4x plus 1, and then I wrote the leftovers, which was 3x plus 2, right next to it. So that's the final answer. We start this for unboxing the same way we did on the front. We put the 6x squared in the first box and the minus 2 in the last box. We do have to multiply those two numbers together, so 6 times negative 2 is negative 12, which means we're going to be finding the factors of 12 that subtract to give us positive 1. So we already know it's going to be 4 times 3, and it's going to be 4 minus 3 to give us our positive 1. So I'll put positive 4x in this box, and I'll put negative 3x in this box. And now we just have to go through and find the GCF in each row and in each column. So the GCF of 6x squared and 3x, you can divide both of them by 3, and you can divide both of them by x. I'm not worried about that negative sign because I know it's going to come out with the negative sign that's below it. So I'll go to the next row, the bottom row. The GCF of 4x and negative 2 is 2. The GCF in the first column, we can divide 6 and 4 by 2, and we can divide x squared and x by x. And I have the negative sign I know I'm going to pull out here. And the GCF of 3x and negative 2 is just 1. So those are the two factors, my 3x and positive 2, and then 2x and minus 1. And that answer is the exact same answer we got when we did the problem over here. The setup for 3b, we still look to see if we have a GCF we can divide all three terms by, and we did. We had a 3x. So I'm going to worry about the 3x at the very end, and I'll write the two factors next to it once we get them. But for now, I'm just worried about this part. So I put the 12x squared in the first box, I put the 2 in the last box, and now I need to multiply the 12 and 2 together, which is 24. So I need my factors of 24 to add up to equal positive 11. We already know it's positive 3 and positive 8. So I'm going to put 3x and 8x in the boxes. Doesn't matter which one I put in the bottom or the top one. And now I'm going to pull out the GCFs. So all the numbers are positive here. I don't have to worry about any negative signs. The GCF of 12 and 8 is 4 and also an x. The GCF of 3x and 2 is just 1. The GCF of 12x squared and 3x is 3x. And the GCF of 8x and 2 is 2. So here we have our factors. The 3x, because it was the GCF that I kept copying, there it is. And now the factors on the sides, I have 4x and plus 1, and 3x and plus 2. And that answer is the exact same as what we got over here. The last thing you need to do is write down if you prefer factoring by grouping, like we did on the left side, or by unboxing like we did on the right side. It's up to you. It really doesn't matter to me either way which you do.